Now let us study the classifications of system. So we understood what is a system. Now we need to system what are the understand what are the different types of system. Okay, so here the first one is the open system. Okay, so in an open system, so here this is our system. This is the region under study maybe. Okay, so open system means there is an exchange of matter. That means mass can escape from the system to outside, also mass can come in, and also the heat energy can be exchanged. Okay, heat can flow in or out. So that is an open system. For example, if you take a water, if this is our system, this water is our system, that means it can evaporate. So that means water molecules can escape, and also this sometimes water vapor molecules can condense. So this is an open system. And also energy can see, it can exchange energy with outside. Okay, if it is hot, then heat will flow from inside to outside. If it is cold, heat will flow from outside to inside. So that is an example of an open system. For a closed system, uh, that means if it is closed by a lid here, that means there is no mass can escape this system. But heat, see, that means if this is not an insulating material, that means heat can easily flow in and out. There is no issue. Okay, if it is not an insulation. So that is an example of a closed system. That means mass cannot be exchanged, but only heat can be exchanged. Then you have the isolated system that is rarely found in our engineering applications. That means it is completely closed. That is, it is insulated from outside. That means no heat can exchange, no heat, so and no mass, no matter. So this is not allowed. So this is an isolated system. For example, our thermal flask can be approximated as an isolated system. That means the energy loss is very low. Okay, so this can be approximated as an isolated system. That is not exactly an isolated system, that can be approximated, and mass is also not closing. Usually there is we can say that universe is an isolated system, because whenever there is an energy transformation is occurring is within the universe, and there is no energy flow from outside to inside, because there is nothing outside the universe. Okay, and a closed system can be also called a fixed mass system, because we are studying a fixed mass. Since matter is not exchanged, this mass will remain constant. That is called a fixed mass. So uh, these are the important classifications of a system, that is open system, closed system, and isolated system. So let us see an example here. So you can see that, so this is the gas we are studying. This is a closed system. Okay, because this is the gas under study, and gas cannot come in and go out. That means that is why it is called a closed system. But energy can come in and energy can go out. There is no issue, right? But you can see that, see, you can supply heat then. That means energy can be supplied in, because this is a closed system. Okay, so when energy is applied, these gas molecules will gain energy and pressure increases, and this will push the piston outside. Okay, this will push the piston outside. Finally it will occupy a position here. Now the gas occupies this much volume, right? So you can see that here this boundary is not fixed, of the closed system is not fixed. The boundary is continuously moving. Okay, that's why the boundary of a closed system need not be fixed, it can be moving. Okay, so this one example of a closed system. And an open system, we will call it a control volume, because in open system what we are studying is not a fixed mass. We are just studying a region in space which is called control volume. Okay, so we are studying only whatever that is coming in and going out. Okay, we are studying a region in space or a volume. okay, or a volume in space. So we are bothered about what is coming in, what is going out of that control volume. So that is why open system can be called a control volume and a closed system can be called a fixed mass, because that mass is constant. There is uh, because there is no exchange of matter. So these are the difference between open system, closed system and isolated system. Now let us see some of the important examples of open system also. Open system examples are, you can take the water heater that is in your house. So here, uh, water heater, you can take a dotted line. This is called the control surface. Okay, this is an open system because matter can come in and matter can go out, and also energy can come in. Okay, because there is a coil through which electrical energy passes. Electrical energy passes, and this electric energy is converted to heat, and so there is an energy exchange. So this is our control surface, or you can call this the control volume, through which water comes in and water goes out. This is an example of an open system. Another example is a radiator. You can see that radiator is used to cool that engine, and there is a water circulating inside this through this radiator, and this water is absorbing energy from the engine, and then a that is transfers to the outside through this fan. So you can see that this is also an open system or a control volume approach. You can use a control volume approach because there is an outlet pipe from water comes out, and there is an inlet pipe, water comes in. Okay, so these are all examples of an open system. So another example, maybe you can see here, there is it's a power plant. Here you have the compressor, jet engine, engine power plant, jet engine. See, there is a compressor through which air is coming in and get compressed, and then it is passed through a combustor. It passes through a combustor where you are adding energy to the compressor by burning fuel, and this passes through the turbine where when the high pressure gases pass through the turbine rotates, so exhaust is moving outside and this current is produced through in a generator. So this is also an example of open system because inlet air is coming, there is an exhaust air. You can take all of this as a control volume. Okay, so this is an open system, this energy exchange, and also there is a mass exchange. So these are all examples of an open system. Now, let us take a specific example, that is a nozzle. So, what is a nozzle doing? It takes in air and increases the velocity of the air. So, that means if a fluid or air comes in with a low velocity, air is flowing out with a high velocity. So, that is the function of the nozzle. Now, this is a perfect example of an open system because you are taking a region in space. Okay. There is a control volume. This is called the control volume. We are only bothered about whatever happens inside this control volume. So that means air or fluid comes in, air or fluid goes out. So this is the boundary. So this is the real boundary. See, real boundary means the surface of the turbine. This here you are taking an imaginary boundary, just drawing this dotted line near to the surface. Okay, this can be imaginary. Real boundary is actually this nozzle surface. So you can also draw an imaginary boundary and study what happens through that, what happens in that space. Okay, so this is another specific example of an open system. Okay, you can take that once more the example of this water heater. Here the water heater, you can see that we have taken an imaginary area, that is the control volume. So to this imaginary control volume, water is coming in and also hot water is going out, and this imaginary area is called the control surface. So I have just shown here the control volume, the region. Now let us see what is an isolated system. See, isolated system, I told you this does not occur in nature or anywhere, because I told you this thermal flask is an approximation of isolated system, because you are taking a system which doesn't have any energy transfer as well as mass transfer. Okay, this is the thermal boundary. So maybe universe is a perfect example of an isolated system. So whatever happens inside universe is not going outside. So there is no exchange of mass as well as energy from the universe. So universe is an isolated system. Otherwise, you can take the example of a thermal flask. Although the energy transfer is very slow, so you can approximate this as a isolated system. Okay, that means there is no heat transfer and also there is no mass transfer.